This is me, Sudha Srikanth, and this is my affiliation. It's been a long time since I made a video. I have had a good break. I discontinued for some time for some reason. Now I have resumed this activity, and I thought I'll make more videos on network analysis. I have made few videos on mesh current analysis method. Problem number 1 to 4 could be you can have a look at them for they are the elementary problems. However, I have taken up this problem, which is slightly tricky. There is no complexity about it, but then we may have to be little careful while writing the mesh equations in this network or loop equations in this network. Okay, so having said that, we will go ahead with the problem. Okay, so we can identify 3 meshes here. So in the problem, it states that determine the loop currents. Okay, the word loop and mesh, they're interchangeably used most often than not. However, there is a distinction between loop and a mesh. Mesh is what we call as the smallest closed path. Smallest closed path. What example I normally give in my class to students is, if this entire thing is a house, you can see there are 3 rooms kind of. This is room 1, room 2, this is room 1, this is room 2, this is room 3. So those small parts, closed paths, is what we call as meshes. Okay, that's how I normally give an example for students. Or if you can imagine this as a window, that is another way of looking at it. If that is an entire window, then these are the panes. These are the panes. 1, 2, and 3 are the panes. So meshes can be seen as panes of a window. Alright, so I'll write this. This is mesh 1, this is mesh 2, and mesh 3. They respectively carry currents I1, I2, I3. Then what is a loop? Interestingly, loop is also a closed path. But then it need not be a smallest closed path. Alright? So if I can look at this network, I can define a loop as this node A, node B, node C, and node D, and back to node A will make a loop. Alright? So alternatively, we can go for A to B to C and this way. This is also a loop. Via the source. That is also a loop. Okay, so you have to have a distinction between loops and meshes. Okay, though one interchangeably uses these terminologies. Okay, now how to go ahead with this problem? Loop is essentially a closed path. That has to be remembered. Okay, what I mean is, mesh can be a loop. Loop need not be a mesh. Need not be, It need not be a mesh. Alright, so that is a distinction. However, we will now solve this particular problem for the loop currents. Okay, loop currents or mesh currents. See, he has used the word loop currents here. But typically, you should have used the word mesh currents. Anyway, it doesn't matter. So how do we do? So we will try to write by first principle. Okay, we will make use of first principle and write the equations. Why first principles? Why not by inspection? You can even do it by inspection. Writing the equations by inspection is the advantage of this analytical method. However, in this problem, if we can see, this branch DB has got a current source. Okay, so the voltage across the current source, how do we consider? What is the voltage across the current source? It is little difficult. It is a difficult proposition to find out. So basically, when we write Kirchhoff's voltage law to meshes, we try to take the potential differences across various elements. That is a fundamental principle. KVL is the fundamental principle using which we arrive at mesh equations. So we try to consider the potential difference across each element and then write the equations, right? So the voltage across the current source is little difficult to find out. So we want to avoid this current source in the problem. That's number 1. Number 2, Another thing that is worth noting is there is a resistance which is in series with the current source. This 2 ohm resistance is in series with the current source. So when you have a resistance in series with the current source, it doesn't have any role to play. In other words, the energy that the current source delivers would be always at the mentioned value. What I mean is, if this is the current source branch that we have taken, dB, this is my 2 ampere current source, this is my 2 ohm. What is the current that the source drives out of its terminal? So this current source 2 ampere will send out a current of 2 ampere in the direction of D to B. The current flow is from D to B or from left to right. Alright? So whether you have, so obviously the current through this 2 ohm is also 2 ampere. So whether you have 2 ohm here, 10 ohm here, 5 ohm here, it doesn't matter. It really doesn't matter. So this resistance can be removed and replaced by a short circuit. It only has to provide a path for 2 ampere to flow. Okay, so any amount of resistance here in series with the current source is redundant. It doesn't have any role to play. So that is something that we need to take into cognizance here in this particular problem. Alright, so with these notes, we will try to go ahead with the problem. Okay, now I will remove this 2 ohm resistance also. Even if it remains, it doesn't matter because we are not going to consider that path at all. Anyway, I have replaced it by a short circuit. So you should know the advantage of this also. Okay, now we will try to write the mesh equations. So what I do is, I'll try to write it by first principle. Okay, so we will writing mesh equation for my mesh number 1. Equations for, I will write mesh 1 first. Okay, how do I do? I'll do by first principle. So when I talk the first principle, what I mean is I'll try to take all the potential differences across various elements, then add it up, then write an equation. Okay, so I will start from the top left corner, from this junction, from this node, go like this, go via this 10, go via this 5, 50 ohms and come back. That is the path I would trace. Alright, so first element that I come across is 10 ohm and the difference in potential is 10 into I1 minus I2. That is the drop in potential. Okay, so if I want to separately show this for the benefit of people who are little, find it difficult to follow, this is my 10 ohm resistance. This is my terminal A or node A, this is node D. How is the current flow? I1, if we can see, is flowing from A to D. Agreed? Whereas current I2 is flowing in this direction. It is D to A. This is my I2. Okay? From A to D, the magnitude of current is I1 minus I2 through 10 ohms. And this is the one which is responsible for a drop in potential from A to D. Okay, current flow is from A to D. We are also going from A to D, higher potential to lower potential, drop in potential. The magnitude of the potential difference is resistance times the current. So plus sign. Alright. Suppose you want to consider I2 minus I1 to be the current in this direction, then it becomes 10 minus 10, I2 minus I1. Both are same. This is rise in potential. This is drop in potential. I suppose this potential difference concept is clear to you. I only hope so. Okay. So now what I need to say is, we will now try to take this element. Which one? 5, 10. So I have come up to point D. Now from D to source, I have to go via 5 ohm. So what is the current through 5 ohm? 5 into that current is supposed to be, loop current is supposed to be taken greater. I1 minus I3, because that results in a drop in potential which we are taking it as positive. What is our sign convention? We try to take drops to be positive, voltage gains are negative. This is the sign convention I follow. Alright, so 5 times I1 minus I3 is the potential drop from D to C. Okay, now, and from C, I have to go back to the top left corner of mesh 1. I would come across a source of 50 volt. So, if I go from bottom to top, I am going from negative of the source to the positive of the source, that is rise in potential minus 50 equal to 0. I came back to the point from where I started. Okay, so we are able to write one equation. We will try to now group the terms and see how the things are going to be. If I expand this, this will be 10I1 minus 10I2 plus 5I1 minus 5I3 minus 50 equal to 0. That would be 15I1. I'll use a color now. 15I1, I'm adding the terms. That's 10I1, 5I1 minus 10I2 minus 5I3 equal to 50. Equation 1. This is how we write it by first principle. So if I write by first principle, I won't make mistakes. If I write it by inspection, I have to be very careful. Otherwise, I may end up making a mistake. Now, let me try to write the equation by inspection. How do we write the equation by inspection? We will try to see. Okay, how to write the equation by inspection. So, whenever we consider a particular mesh, we try to add all the resistances contained in that mesh and give a positive sign. So, mesh 1, I1 current, all the resistances contained in mesh 1, that is 10 ohm and 5 ohm. This 10 ohm, this 5 ohm. That would be 15 ohms, right? So, I will write it as 15 I1. That is given a positive sign. Okay. Now, what is common between mesh 1 and mesh 2? That resistance is given a negative sign and multiplied with the other mesh 2 current so that you get the potential difference. Applying that logic, the resistance is 10 ohm, which is common between mesh 1 and mesh 2. It is something like a common wall between two rooms. Alright, so it is 10 ohms. 10 ohms resistance is common between mesh 1 and mesh 2. So when we write the first equation, this common resistance is given a negative sign, minus I2, provided the currents are taken in the clockwise direction. All the currents are taken in the clockwise direction. That you have to remember. Okay, so 10I2. Now what is common between first mesh and the third mesh? It is 5 ohm resistance. That again is given a negative sign, minus I3 equal to the sum of the EMFs contained in that mesh with voltage gains to be taken positive on the right hand side of the equation equal to 50. This is same as this equation, right? It's also equation 1. See, one can apply first principle and arrive at the equation. One can apply, the inference that we deduce from this elaborate method of applying KVL to meshes and writing the equation. So, whichever way is convenient, you can follow. Ultimately, the idea is to be correct. Okay? So, this is how we write one equation. How do we write the second equation? I will clear all these extra lines that I have written so that there will be clarity. Okay? Now, how to write the second equation? It's very simple. Another equation can be written in terms of I3 and I2. If you look at this 2 ohm resistance, 2 ampere current which is flowing through this branch dB, the current 2 ampere, this is 2 ampere current. Here in this branch, the current is 2 ampere. Okay, this 2 ampere current has to be the difference in the currents between I3 and I2. It's very simple because the mesh currents are I3 and I2. The difference between I3 and I2 has to be 2 ampere. It is something like this. I will show you here. I'll erase this eventually. This is my 2 ampere source. If you want, you can even have this resistance back. This is your 2 ohm resistance. This point is your D and this is your B. Right? Now, in terms of mesh currents, this is my current I2. And the current I3 is flowing this way. Okay? 2 ampere is in the direction of I3. So, obviously, your 2 ampere should be equal to I3 minus I2. Okay? So, the two currents are in opposite direction. The net current is the difference between the two currents with the direction equal to or same as the higher current. That is I3 minus I2. Okay? So, this is the logic we have. So, you get one more equation in terms of I3 and I2. Okay? So, in terms of I3 and I2, that can be written by inspection. By looking at the network, you can write. You don't require anything else. Okay? The second equation that we now write is, I3 minus I2. Okay, I will write it as I3 minus I2. Okay, minus I2 plus I3 equal to 0. If you want to even put 0 I1, you can put. This is equation 2. Alright, now how to write equation 3? So what I do is, I will try to copy this network. Where do I have copy? I have copy here. I'll take it here, paste, so that we can write the third equation without having to scroll up and down every now and then. So how to write the third equation? How do I write it? How do I write the third mesh equation? Now, my third equation, I will write it by inspection. How do I write? I will try to now consider the loop equation. Okay, so what is the loop that I follow? I follow the loop A, B, C, D and A. So what do I do by doing this? I am avoiding this 2 ampere current source. I am trying to find a closed path. I am trying to get equations in terms of I2, I1, I3. But I am avoiding 2 ampere current source. That is the reason I have defined this particular mesh. And some of the textbooks on network analysis refer to this kind of a mesh as super mesh. This is supposed to be a super mesh. Whether you know this terminology or not, it hardly matters. We must be able to get the currents right. Now we will start. We will use first principle. Again, I'll start from this left corner, top left corner. I'll take the path like this. Then I'll go this way. I'll go this way. Then come back to A. That is the path I tend to take. Okay? I'll use first principle. First I'll write by first principle. Then we will write by inspection. Alright? So from A to B, I'm meeting 2 ohm resistance. Okay? So what is the potential difference across 2 ohm? 2 ohm resistance is carrying I2 ampere of current. My direction of flow, current flow is in the same direction. Drop in potential, it is 2I2. From B to C, how do I take the potential difference? Again from B to C, there is a drop in potential because current I3 is flowing from B to C. It is a drop in potential. What is the magnitude of the drop in potential? Obviously the sign is positive. It is 1 into I3 or simply I3. Now I go from C to D. From C to D, I am taking I3 current. I am talking about I3 current. I am going in the direction of I3 current. And it is going to produce a potential difference of 5 into I3 minus I1. Okay? I am going from top to bottom, rather bottom to top. My current I3 is also flowing from bottom to top, that is C to D. So that current I am taking it as greater. So 5I3 minus I1 is the drop in potential. I have come up to D. From D to A I will have to go. Now what is the current that is flowing through 10 ohm resistance? The current that is from D to A, if I consider D to A through 10 ohm, it is I2 minus I1. So you may have to be very careful. Equal to 0. This is my equation. Okay? We will try to club the terms and see what is it we get. Okay? So we have got, I'll group all the terms. I'll expand only. Then we will group. 2I2 plus I3, 5I3 minus 5I1 plus 10I2 minus 10I1 equal to 0. We need to group. Okay? So what are the terms that we have? How many? We will group I1 terms. Minus 5I1 minus 10I1. A child will say it is minus 15I1. Okay? How many I2s are there? 2I2 here, 10I2 here of the same sign. That would be 12I2. Okay? Then there is this 5I3, there is I3. That would be 6I3 equal to 0. This is equation 3. Done. 3 equations, 3 unknowns. Calculator, you feed the matrices, you will be able to solve. Now, can we write this equation 3 by inspection? Can we? You can. If you look at this particular loop ABCDA, it encompasses all the 3 meshes. It includes all the 3 meshes, mesh 1, mesh 2, mesh 3. Okay? So you may need to take the currents properly and write. Okay? We may take the currents properly and write. We will try to take the currents, right? So I2 and I3, we will take in the clockwise direction. Okay? So if you look at mesh 2, okay, how many, what are the sum of the resistances that it has? It has got this 2 ohm resistance and this 10 ohm, I'll take a different color. It has got 2 ohm resistance, it has got 10 ohm resistance. Okay? So I2 is flowing through these 2 resistances. So that would make it 12I2. Okay? I'm talking about this portion. Okay? Now, as far as I3 is concerned, I3 is flowing through this 1 ohm resistance and this 5 ohm resistance. That would make it plus 6I3. Okay? Now, if you look at the other mesh currents, that is I1 is flowing through 5 ohm, I1 is also flowing through 10 ohm. It is the other mesh current which would make it minus 15 I1 equal to 0. So, you can write it by inspection also. But you have to be a little careful while writing the equation by inspection. The chances are there that you may make a mistake. So, first principle will never let you down. So, writing the equations by first principle is always a good way of writing the equations, unless you are very, very competent, very good at it. Okay? However, our problem now boils down to solving 3 equations and 3 unknowns, and the results can be easily obtained. Now, we will collect the equations. Should we collect all the equations? Where is my equation 1? I will pick equation 1 carefully with my selector. Okay, I will carefully pick this, copy, I'll paste it here. Some additional things also came along. I can remove that. Where is my I2 equation? Okay, equation 2. I'll copy this equation also. I'll put it underneath this. This is my equation 2. Okay, I'll align it properly. And I'll take equation 3. I'll copy this equation. put it underneath. This is my third equation. Okay, so we have 3 equations and 3 unknowns. Now we will solve. Solving equations 1, 2 and 3. We get, if you can feed it in the calculator, okay, you can get the results to be equal to, I will write it here, I'll write it, I1 equal to, you will see to it that I1 is equal to 20 ampere, I2 you have to get it as some 16 ampere, and I3 you will get it as 18 ampere. This is how you get the results to be. Okay? You can write it this way. This is your result. The 3 are the loop currents. You can write these equations in what we call as vector matrix form. How do? We will write the resistance matrix or impedance matrix. It is something like this. R into I equal to V. This is in matrix form. This is what we call as matrix form. This is your algebraic nature. These are your algebraic equations. Okay, so you can put it in matrix form also. How do we write that? This is 15 minus 10, the element of I3. The coefficients of I1, I2, I3 along with their signs are taken as the first row from first equation. Second equation, there is no term of I1, that will be 0. The second term, I2 has got a coefficient of minus 1. I3 has got a coefficient of plus 1. Similarly, from third equation, we have minus 15 coefficient of I1, plus 12 coefficient of I2, 6 as the coefficient of I3. This is my resistance matrix. This multiplied with the current matrix, which is our unknown. I1, I2, I3. Oh, I made a mistake here. Where is that? Even here? I'm sorry. I'm so sorry. This is 2 ampere. How is it I missed that? Obviously, here also it is 2 ampere, not 0. Okay? I'm sorry there for the error that I've committed. This is equal to. Good that I corrected it. It is 50, 2 and 0. 2 and 0. Okay? So we are able to write 3 equations, 3 unknowns. So this you solve, you will get the same thing. You will get the same thing. This is how you do a problem of this nature. Okay? So while forming the loop, you try to avoid the current source. Try avoiding current source and then you'll be able to do. So more problems of this nature I intend taking up because they are the tricky ones and we can work it out. So if you have any difficulty, you can put it in the comment section. Any suggestions for improvement of videos, or if you have any typical problems to be taken up, you can always post. I'll be too glad to take up those videos. So hope to continue making more videos on a network analysis. Thanks for watching. Your feedback is definitely going to be valuable for me. So with this note, I will say see you in the next video. Thank you for watching.